We come along and we position ourselves as a coprocessor to Snowflake. So we add support for things like graph analytics, rule-based reasoning, predictive analytics, prescriptive analytics. And now all of a sudden, in a very clean way on one platform, you can actually pull all this together and build really sophisticated, really intelligent apps, and then layer on the Gen AI now that lets you create agents that help you use the apps and help you streamline the user experience around that. It just becomes really amazing.
Molham, welcome to the show.
Thanks, Julian. Happy to be here.
To get things started, I would love to hear a little bit about kind of your path, your career, what took you to Relational AI, and then sort of what are the customer challenges and problems that Relational AI is solving today?
Sure, I'd be happy to tell you a little bit about that. So I started being interested in computers at a relatively young age, wanted to learn how to program, how to use them. Always fascinated with how do we get computers to, automate things on our behalf or to make decisions for us or to be smart like us in some ways. And so after studying to be a computer scientist and a software engineer and a computer engineer, I started working in computer vision systems. This is a long time ago, much older than you, Julian. In the early 90s, I worked on computer vision systems, initially to do document understanding, but eventually to kind of look at video and understand what's going on. From there, I went to start working with early generation neural networks when neural networks were not very deep outside of one hidden layer. And I learned a lot about how enterprises, how companies use machine learning, AI, they didn't have those terms back in the 90s. They were called data mining and computational intelligence and things like that. But how those things are used in the enterprise. And for a long time, for most of my career, it was very, very hard to build applications that leveraged AI because you had to combine a variety of technologies. And I'll tell you more about that as we go. But that's really what motivated me and my colleagues to start Relational AI. It's just too hard to build intelligent applications. And we've been there, we've done that, we have the battle scars, and we wanted to build on what Snowflake did to make it easier to build intelligent applications.
So I really like kind of this journey you've been on with things that we still do, like data mining and all these other pieces, even though we're in this, call it Gen AI hype today. As customers are kind of thinking about their tool infrastructure decisions, what are some recommendations or things they should think about based on your experience from the early days?
Yeah, so first of all, I think Gen AI is amazing. Sometimes, like any technology, and I've seen this happen multiple times over the last 30 years, something as amazing as Gen AI, it's very natural to exaggerate and hype it up, okay? But Gen AI is important, it's amazing, it's here to stay, it solves problems that we couldn't solve before. But before that, in 2017, we had deep learning, and that was amazing. And it was a precursor to what made Gen AI possible. And all of a sudden, we were able to do machine learning on images and on text without having to do feature engineering. That was pretty cool. Before that, I mentioned sort of my experience with early versions of neural networks with the one hidden layer, and that was a big breakthrough and made certain things possible. Before that, we had breakthroughs in mathematical programming and solvers of a variety of flavors, things like that could do linear programming, integer programming. The stuff that runs the world today, it's so important. It drives every supply chain, it drives many, many industries, and we take it for granted that it's happening. It's so much so that some people don't even know that it used to be called AI at some point. We had the same with expert systems and rule-based reasoning. So over the years, we've developed a suite of technologies that we can pull together to solve really hard problems in the enterprise, problems that help automate and improve decision-making. Because at their core, most businesses are trying to figure out how to allocate capital, how to allocate money to various things so they can get more money back, okay? A business is a machine that takes money in, hopefully produces more money out. And so where do I put that money? Do I put it in more inventory? If so, which kinds of inventory? Do I invest more in electronics or more in grocery products? Do I put it in labor, so I put more employees in the stores? Do I put it more in new channels like online channels? Do I put it in manufacturing equipment? Do I put it in, spectrum? I have so many things, the real estate, so many ways to deploy your capital as a business. And you want to be able to predict, hey, what kind of financial return will I get if I do these various things? And then you want to be able to, through the use of prescriptive analytics like solvers, make a decision on which of these million options is going to make me most successful. Okay, so the key theme here is when we were putting together these applications over the last 30 years, we had to base those applications on at least 5 different technology stacks. The OLTP stack, the bookkeeping stack, the operational stack is one. The analytics stack, sometimes called descriptive analytics, sometimes called OLAP. It's a planning stack, companies like Anaplan and Hyperion and things that let you do planning in a forward-looking way. The predictive analytics stack, which is many, many different techniques, including statistical modeling, neural networks, simulations, and so on. And then a 5th stack around the prescriptive analytics, all the solvers and all of that. And that's became, even though the problems we were working on were very cool, putting together all that glue became soul crushing. It made it not fun to do this work because you spend 90% of your time just duct tape and chewing gum and paper clipping your way through all of that. Okay, and so with the advent of Snowflake and with the advent of cloud native architectures, you revisit all of that. Does it have to be so hard? Especially when you have a foundation like Snowflake that gives you a lot of workload support, not all the workloads that you need for this, but gives you a great scalable, integrated starting point. And then we come along and we position ourselves as a coprocessor to Snowflake. So we add support for things like graph analytics, rule-based reasoning, predictive analytics, prescriptive analytics. And now all of a sudden, in a very clean way on one platform, you can actually pull all this together and build really sophisticated, really intelligent apps. And then layer on the Gen AI now that lets you create agents that help you use the apps and help you streamline the user experience around that. It just becomes really amazing. Much, much better applications than we were ever been able to build for much less time, much less money, much less effort.
Yeah, and I really like how you kind of focus it back on what do companies want, and what they want is an ROI, and what is the fastest way to get that ROI. So I really like that approach. Now, how does technology then turn into use cases, and what are companies actually doing when combining Snowflake and relational AI today?
Yeah, I mean, there's so many ways to kind of improve the operations of a company and to capture opportunities and so on. So it's just some examples. So one example for graph analytics is sort of helping companies improve fraud detection and insider threat detection. If you went to Summit a few weeks ago, you would have seen AT&T in the main keynote talk about how they leveraged relational AI as a native app on Snowflake to do these amazing things, saving them many, many millions of dollars, and doing so with way less effort than it would have taken to do that. We've had other customers in the tax space and accounting space, financial services space, leverage rule-based reasoning to take applications that were written in hundreds of thousands of lines. In one example, 800,000 lines of C#. We re-implemented that as a knowledge graph and reasoned over tax laws and tax policy in about 15,000 lines. Okay, we have another example, also a talk at Summit with one of our customers, Blue Yonder, supply chain company, does a lot with mathematical programming, integer programming, linear programming. We took a legacy application that was almost 500,000 lines of C++. 205,000 lines of that was the core business logic. In about 8,000 lines of SQL and rules, we had the same backend, and it was much better user experience and much cheaper to operate, and more efficient, more scalable, and so on. So, as you see a lot of these smart applications, they don't use just one technique. They will use a combination of these techniques to pre-process the data, post-process the data, to use solvers, to get predictions. And being able to do that on one platform instead of, the data starts off in a database and then you pull it off and put it into, 4 or 5 other technology stacks. Now it's just all in Snowflake. It's secured in the same way. It's governed in the same way. You don't have to worry about data synchronization issues. The architecture is cloud native. So all the great things about Snowflake that made it better than Hadoop and all the old technology like time travel, zero copy cloning, versioning, accrue to all of these things, consumption pricing. And because it's all relational, it's all very compatible. It's sort of the same paradigm. One thing we heard a lot of at Summit, as you build intelligence into applications, you can't afford to move the data to the app. You move the application logic to the data, okay? And so with us as a coprocessor, you can do that. And of course, the paradigm of data is a relational paradigm. And so you want your semantics, your logic, your knowledge, as close to the data as possible, and also implemented in sort of in the same architecture, the same paradigm.
So agree with a lot of the stuff you're saying, especially in particular, as I was hearing, right, the focus on data security being so important to protect data as part of all this AI functionality. Now, you mentioned a customer like AT&T, and you started mentioning different use cases. To make it more tangible, we'd love to see a demo of one of those use cases you mentioned.
Yeah, I would love to show you. So I'm going to use the same demo that we showcased at the summit, which is a demo of a fictional company called Tasty Bytes, which is a food truck company. And the idea there is, can we figure out from the transaction data that this food truck company is collecting, who the groups of customers, how customers are connected to each other, okay? And if you were at Summit, you'd remember that our customer Cash App came on stage and talked about using graph analytics and in a different context, described very extensively that process, and that's sort of what led to us going into a Tasty Bytes demo. Okay, so what I have here is a VS Code notebook. I went ahead and sort of ran through this so we can manage our time together. But you'll see a community detection and group recommendation demo, which we can get from the Solution Center. I'll show you that later. And we just talk you through the process of configuring this as a native app in Snowflake. And so as we know, the languages of Snowflake, the primary languages of Snowflake are SQL and Python, and this demo is all configured in Python, which is not something people normally are able to do when they're working with knowledge graphs and working with the workloads that we are supporting here. And this is one of our innovations, is that you can stay in SQL and Python and get access to these very sophisticated knowledge graphs that support the workloads that I told you about. Okay, so first section here, we import the right libraries. We set up the Tasty Bytes demo. Again, Tasty Bytes is a food truck business. We're trying to understand how customers who buy food from various food trucks relate to each other. And then we just create a mapping from the data in Snowflake to this knowledge graph that we're creating. And really what we're doing here is, in effect, introducing a new kind of table into the Snowflake world. You know, you have regular tables, you have hybrid tables, you have dynamic tables, and so on. And this is sort of a set of tables or views that map onto the underlying Snowflake data. And these things are just like dynamic tables. They're like normalized dynamic tables. And so once you've created this knowledge graph, your data stays in sync in the same way that they would stay in sync with dynamic tables. Okay? All right, so first thing we want to do here is just query how much data we have in Snowflake. And you can see we have 1.6 million records, so it's not a insignificant data set. Next thing we want to do is we want to set up the core concepts, the core types in our knowledge graph. So in our knowledge graph, we have a notion of a customer. Okay, that's something that we want to understand as a business. We have a notion of a truck. That's where people buy our stuff. We have a notion of a transaction, which is, someone, customer, bought something at one of our trucks on a certain period of time. We have a notion of community, which is the thing that we're trying to measure here, because as customers buy like one at a time, we want to understand which customers actually come to our food truck together and form a community. Okay, and we want a concept of connections that are made that are relevant for the analysis that we're doing. So once we've created these concepts and these types, then we can then move on to define certain rules and rule-based reasoning to let us map elements of the data to our customer concept. And this is exactly what we're doing here. And after we've done that mapping, we run a query to basically count the number of customers in the data, and we can see there's 10,613 customers. Okay, we do the same thing for trucks. We define a rule that lets us sort of extract the examples of trucks in our data sets, and you can see the Tasty Bytes business has 15 food trucks. Okay. And then we want to kind of also model out transactions, and you can see here we're modeling a transaction as a customer with an order and a location and then a timestamp around when that order happened. So, the business problem we're trying to solve here is we had one food truck that served cold food, and we want to make sure we understand, which customers experience that. We want to be able to communicate with them and connect with them as a group. And so if Todd and Jane and Fred all form a group, and let's say Todd had a bad experience, we want to know that happened, because we want to be able to communicate with Jane and Fred as well and make sure that, Todd doesn't create a problem for us. Okay? So how do you do that when people might be buying your product sort of independently of each other? Okay? But because buying food is a social experience a lot of the time, what we thought we would do is do a quick analysis and sort of say, all right, let's get all the connections of pairs of customers who bought food from a particular truck within 20 minutes of each other. Okay? So let's say you and I are going to go have lunch together, and if we bought food within 20 minutes of each other, that connects us somehow. Now, it's also possible that you and I don't know each other and we just happen to buy food at the same time. So this is an interesting analysis, but it's not enough. Okay, so when we do this analysis, we identified something like 1.2 million pairs of connections of people buying food from one truck around the same time. But we don't think that's enough to kind of inform us that we're somehow connected. Okay, so the next step here would be to see and count how many times we did that over all time. Okay, so if we did that 5 times, if 5 times on 5 different days with 5 different potentially food trucks, we ended up buying food at around the same time, we're going to classify that as a relevant connection, as a connection of us going to lunch together. Okay, it would be too much of a coincidence if we're buying food from the same truck at more or less the same time 5 times and we're not actually coordinating our lunches. Okay? And that's really basically what we're doing here, is basically counting the number of times pairs of people do this. And here we set the threshold to be, if it happens more than 4 times, so 5 times or more, then that means we're friends. Okay? And once we identify those friendships, then we want to basically do an analysis. In this case, this is something called the Louvain analysis, that you give it the friend edge, the friend relationship, the people who are connected to each other as friends, and then you say, all right, go connect all these friends to each other and give me communities of people that know each other and can influence each other. Okay, and that's what we do here exactly. And then once we've done that, we can visualize the graph in a variety of ways. We're using a standard Python library to do that. As you can see here, we have a graph that shows us sort of various connections, various communities. You can look around and visualize all this data and zoom in and zoom out. And then we can then label communities of interest, okay? And then here you can see, label in color, you can see that we've identified this group of people as a community, and at least one of them had a terrible service experience, and we're going to try to get in front of that and try to make that right before our brand and our reputation is impacted.
Yeah, no, thanks for showing me that demo. And I think to something you said earlier, in just a few lines of code, you were able to do something pretty advanced. But I know this is just one of the use cases we talked about. What if I want to try demos across other use cases? Where can I go learn more about that?
Yeah, so I appreciate you asking that. So if you go to our website, let me see if I can bring up a browser. And well, a couple of things. You can go to our docs, and you see here we're starting out with you're sharing a variety of example notebooks. So the example that we just discussed is community detection. You have a notebook that shows you how to detect money laundering. It's very important for banks to make sure that they're not involved in money laundering operations. Examples are on data harmonization. You have lots of different data silos and you want to harmonize it and make it coherent. Examples for understanding user behavior better, traversing decision trees, and also examples are pertaining to specific graph algorithms like betweenness, centrality, and infomap, and so on. Again, our friends at Cash App talked quite extensively about their experience using infomap to detect communities in their world and why that's so important for them. The Builders keynote at Summit, I would encourage folks to go check that out.
Yeah, I really like all these hands-on resources so that developers can try it out, see how easy it is, and then of course, take it quickly into production. One of the big things we talked about was the security of the data, right? And the importance of that. And it's typically a very important piece when you're going from development to production. And it's a big shift that is not easy to do. So I was wondering, how did you think about that? And how does the partnership between RelationalAI and Snowflake sort of address that common issue in the enterprise?
Yeah, one of the most compelling reasons for us to build a native app on Snowflake is that we can leverage the investment that Snowflake has made in securing enterprise data. So we think in terms of a handful of cardinal sins, things you cannot do as a data platform. And the number one sin is compromising the security of your customers' data. It's better to lose it than to compromise it. And so Snowflake obviously has made amazing investments in all sorts of ways around this. And what's awesome about being a native app and running an SPCS like we do is we get to leverage all of that. And so you develop in a secure environment, and when it comes time to deploying your application, you just deploy in that environment and basically go live directly in Snowflake. The alternative would be for you to have a point solution for graphs, point solution for rules, point solution for predictive analytics, point solution for prescriptive analytics. If you're going to use the legacy options, that means you have to pull the data out of Snowflake. You have to worry about security and governance. You have to worry about data synchronization. And you do have to worry about that 4 times if your intelligent application leverages these technologies. And so with the architecture that we have here, it all stays in Snowflake. You can just go from development to production and don't have to worry at all about these types of security concerns.
Yeah, and I couldn't agree more with sort of like that increasing agility by having all this sort of built in and making your data secure from beginning to end. No, I really enjoyed everything you've been sharing today. Now, if I want to get started with relational AI, where should I go?
Really easy, www.relational.ai. On the top right corner of the website, there's a Get Started, and that will take you straight to the Snowflake Marketplace, and you ask for the app, and we'll set you up.
Yeah, no, that sounds super easy. Molham, thank you for being on the show today.
Thanks, Julian. Appreciate it.
And of course, thank you to everyone watching. Make sure you like and subscribe to see more videos of AI builders showcasing their applications built right here in the AI Data Cloud.